Welcome back. Today's question is, without question, quite a challenging algebra question. Have a careful think of what you've got. What are you told? Small hint in the corner, which I won't say what it says, so you can zoom in and have a look if you want a little bit of a hint. But either way, have a good go. It might take you a little bit of time to get this. I'll give you no more clues. Back in a minute. Okay, so how did we do? Now, again, this isn't an easy question, but as with all these questions, aside from the hint that I've written, I do think there's often a bit of a clue as to what to do. So for me, the thing that stands out is the y plus 1 and the z plus 1. So equation 2 and 3, there's some symmetry about those two equations there. Whereas the equation at the top, although it has a rotation of x, y, and z, it equals a different number. So I'm going to start by doing equation 2 minus equation 3. Now, again, as I often say when I do these questions, there is not one right way of doing it, but this is the way that I chose to do it. Also, bearing in mind, British Maths Olympiad, there's no calculators. So I'm not expecting any difficult maths here or anything too difficult calculation-wise. I shouldn't have any weird decimal places. So let's go. So equation 2 minus equation 3. So just write the whole thing out. So that's going to give me, well, 2 minus 3 is going to give me y plus 1, etc. I won't read all the algebra out. Now, if I expand that, I can see I've got xyz plus xz minus xyz minus xy. Crucially, my xyz's cancel out. So that just leaves me with x times z minus y equals 0. Now, at this stage, the temptation is to say that I've got integers, but in the question, this is not one of those questions whereby I use integers and that tells me certain things. However, it is still the case if I have a thing times by a different thing and I get 0, one of those things must equal 0. So in other words, it must be the case that either x equals 0 or y equals z or z equals y. And that is, of course, because I need one of those expressions or terms to equal 0. Now, if you look at equation 2, if x equals 0, I'm going to get that 0 is equal to 4. So that's impossible. So therefore, because that's definitely not true, it must be the case that y equals z. Think about what I've done. I've got 3 equations with 3 unknowns. I've managed to turn one of the unknowns into another unknown. So it is always the case for solutions of this equation that y is equal to z. So now I can substitute that into equation 1 and equation 2. I could also do it for equation 3, but equation 3 will then just give me equation 2 again, which is why I only have 2 equations. So now I've got 2 equations, 2 unknowns. I'm going to use the second one. So I'm going to divide by y plus 1 times y, and that's going to give me an expression for x. Now, there are, again, a few ways of doing this, and I think arguably this is the most simple algebra to do, but you could have gone a slightly different way, and you should hopefully get to the same place eventually. Anyway, point is, I've got what I call a and b. If I put b into a, well, that's going to give me this expression here. Now, I want to make sure my denominators are the same to tidy the mess up inside the brackets. So that's going to give me this. And I work out that something is equal to 12. Now, at this stage, I need to be very careful because the temptation here is just to divide everything by y. But I can't do that if y is equal to 0. So if I'm doing this properly, I need to make a clear statement as to why y doesn't equal 0. And it's very similar to one I did above. So in expression 1, if y equals 0, I'd have 0 equals 12, and that's invalid. So it's definitely the case that y does not equal 0. And that's important because that means I can then factorize out to y and divide by y, or I could do that at a later stage. Anyway, point is I do divide by y, multiply by the new denominator, and that gives me this equation here, which I'll rearrange it, gives me this equation here, which I've called f of y because it allows me then to deal with it. Now, again, let's pause for a second. What have we done? We've managed to change three equations with 3 unknowns into one equation with 1 unknown. And now I know what to do. I can solve this. Again, non-calculator, but I can solve this. I have techniques to solve. So let's look at that. Now I'm going to stick to the sort of various GCSE A-level type techniques. I won't do anything too difficult beyond here. So I've got f of y equals this cubic here. I'm going to use a factor theorem. So what I'm going to do is I'm going to guess at different numbers. 1 doesn't work. -1 doesn't work, but -2 does work. So in other words, if I put -2 into this equation here, I do get 0. So because -2 gives me 0, it must be the case that y plus 2 is a factor of f of y. And so that means I can then factorize this first equation here. Now, how have I done that? Well, what I've done is I know that y times y squared is y cubed. So I know that's definitely y squared. I know that 2 times minus 6 is minus 12, so that's definitely a minus 6. And then what I've done is I've done y times minus 6 is minus 6y. I want minus 8y, so therefore there must be a minus y here. So I've basically just done some in my head factorizing to get the right answer. You could do algebraic division, you'll get to the same point. Point is, I can now factorize this again, which is going to give me that y, in order to give me 0, is going to give me two values, minus 2 repeated, and plus 3. And that's pretty much the question done, isn't it? I've got my only two y values that satisfy this equation. I've got an equation that links y and z, because y is equal to z, and I've got an equation that gives me x for a given value of y. So let's just do that. So therefore, I know that y equals minus 2 or 3. In that case, x is going to be equal to 4 over minus 2, the equation that I had on the previous slide, which equals 2. If I put 3 into the equation, I get a third. And so therefore, now how you present this, you can do it in different ways as long as you're clear what you're doing and you're linking the terms correctly. So my final solutions are going to be that x, y, z is equal to 2 minus 2 minus 2, remembering again that y equals z, or it's going to be a third, 3, 3. A difficult but really satisfying question if you've managed to get your way to the end. So if you have done all that, well done. I've got another algebra question coming soon, but I think we're going to go with a bit of an easier logic question tomorrow. So as ever, any comments, please do put the comments below. Please do like the video, it really helps me and frankly just makes me feel better. And of course, do come back for tomorrow's problem. Thanks all. Bye.